Alright, let's do this acceleration worksheet 2. If you have not attempted this yourself yet, you should do that first. And if you haven't watched the acceleration notes number 1, then you should watch those before you do this also. Okay, so go ahead and pause this and go do those things if you haven't yet. If you have done those and you've got your attempt at this, then welcome back. The velocity time graph of a car is shown below. So before we answer any of these questions, just look at this and see if we can figure out what's going on here. Now, this is not a position versus time. This is velocity versus time. Right here, what I'm going to look at first is that at time 0, this car has a velocity of 4 meters per second. And as time goes by, the velocity of the car is changing. It's increasing, and it's going up to, it looks like this is 12 meters per second here. So what's this car doing? It's speeding up from 4 meters per second to 12. Now it wasn't from a stop, right? It's starting with a velocity of 4, and then it's getting faster. How do we find the acceleration? Well, the acceleration here is change in velocity over change in time. If you didn't do those notes yet, it's right in there in your notes, which is the slope. And that's rise over run, right? Slope of a v versus t graph. Has to be the right graph. You can't find the slope of an x versus t and can't have that be acceleration. It's got to be the velocity versus time graph. So the slope of the v versus t graph, let's see, what's the slope here? It looks like it's got a rise of 12 minus 4. And the units here of rise, meters per second, over 5, the units of the run are seconds. So that's 8 over 5, which is 1.6 meters per second per second. These units can be potentially, I'm going to put a 1 on the bottom there, right, over 1. So the units can be a little confusing, but you have to have the right units, and the units are obviously, if we're doing slope, it's got to be units of rise over units of run. So it's got to be this. What does this mean? Well, if you wanted to say the meaning of this slope, always a good idea, for every 1 second that goes by, the velocity increases by 1.6 meters per second. For every one of these, this happens. For every 1 second that goes by, tick, the velocity goes up by 1.6 meters per second. Right? It's the velocity that's changing, so that has to have those units on the top. Write a mathematical equation describing velocity as a function of time. That's just the equation for this line. If that confused you, then all this is asking is for you to write the equation for this line. And we just found the slope, and we know what the intercept is right there. So if you were confused by that, I want you to pause the video right now before I go on and do it, and try again yourself. It's just writing the equation for this line. All right, last chance to pause. I'm going to do it now. So I'm thinking y equals mx plus b, but I'm going to write in all the correct things. So it's not y here, it's v equals the slope is this with the units. It's not wrong if you leave that 1 off. I just like to put that on the bottom. So that's y equals m. It's not x, it's t on this axis, plus b. The intercept is, I don't know, it looks like a negative sign in front of that. It shouldn't be there. Is 4 meters per second. If you don't have those units, that's a mistake. It's got to have those units there. Explain the meaning of the y-intercept. 4 meters per second is the starting, of course, and as we call that, initial velocity. So in other words, when time is 0, That's how fast it was going at the beginning. Predict, oops, there you go. Predict what the velocity of the car would be at 10 seconds. How would you do that? Well, I guess I could make the graph and like make it extend it out there. But I have an equation now, right? So all I need to do, 1.6 meters per second, 1 second, is plug in the 10 there, times 10 seconds plus 4 meters per second. 1.6 times 10 is 16, plus 4 is equal to 20 meters per second. And sketch a motion map that corresponds to the car's motion. Well, I know that when I make my motion maps, that the little arrows that go to the next points are the velocities. They should represent how much velocity I have. So if this is increasing, then the length of those arrows should be increasing. Now the first one's not 0, it's like 4, so if that's like 4 to the next one, right, halfway to the next dot, then the next arrow has to be longer, and then that's halfway, so that's going to make that dot further away, and then the next arrow is longer, and so on. And this is just a sketch of the motion map, so something like that. Use the graph to sketch a position versus time graph. This is position versus time. Now, what is that going to look like? It's not going to be a straight line. If velocity versus time, if this is increasing, that means this is going to be bending. So what does it mean that this is 4 at the start? Well, how fast it's going is the slope of this. So that means like at the very start here, this is not coming flat like this. It has some slope at the beginning. And then as time goes by, 1, 2, 3, 4, 5 seconds, it keeps getting, the velocity goes up, which means this gets steeper. So it must be getting steeper, bending upward like this. Remember this part of the notes? Right? So what's the difference between what we just did here and this? Well, here, this had a starting velocity of 0. So it was flat at the start, and then it bent up from there. And ours had a starting velocity of 4, so it started with a little bit of slope at the start there, and then bent up from there. Calculate the displacement of the car over the 5-second interval. And just a little hint here that we can do that finding the area. So let me go back to here. I'm going to make this into a rectangle. And a triangle. And then I'll just add those areas together. Okay, so what's the area of this rectangle? It's 4 units high and 5 units across, right? Make sure you look at the scale and don't count boxes, right? This is 0 to 5, so there's 5 across, 4 up. So that is 20. And the units of this, units of area, I'm multiplying like length times width. It's meters per second times seconds. So the seconds cancel and I get meters, which is good because I'm looking for the displacement. So that part of it was 20, and then I've got a triangle here that is, its base is 5, and its height, it's not 12, it's from here up to 12, so that's 4 and 12, that's 8 high. So 5 times 8 is 40, 1/2 base times height. That would also have an area of 20. So 20 plus 20, get out my calculator. Just kidding, is 40 meters. And I'm just going to make a picture here that showed that I had a 5 by 4 and 5 by 8 rectangle and triangle. That's how I got that. All right, and then what's the average velocity of the car over the 5-second interval? Well, velocity average is displacement. That's what we just found here. That's displacement over time. So, well, I just did that. So 40 meters over the time interval is 5 seconds. 40 divided by 5 is 8 most of the time. And I just want to point something out to you. That's the average velocity. And that should make a whole lot of sense because I started at 4 and I ended at 12. Do you know what's exactly halfway in between 4 and 12? What the average of those two numbers is? Right, it's 8. And notice that that happens like exactly halfway through the time interval. All right, there's some new stuff going on in there that's worth letting that settle in and maybe coming back and revisiting this at some point if you need to. I hope you have a great day.